For many, a successful cyber attack begins and ends with the initial breach. However, for sophisticated adversaries, gaining initial access is merely the first step in a much larger campaign. Once inside a network, attackers rarely stop at a single compromised system. Their true objective often lies deeper within the infrastructure, requiring them to navigate and expand their foothold. This critical phase of an attack lifecycle is known as lateral movement. It is the process by which an attacker, having gained initial access to one system, moves to other systems within the same network. Lateral movement refers to the techniques attackers use to progressively move deeper into a network from an initial point of compromise. It allows them to explore the network, identify valuable assets, and escalate their privileges. This stealthy progression is crucial for achieving their ultimate goals, whether it's data exfiltration, system disruption, or persistent access. Without effective lateral movement, an attacker's impact will be limited to the initial compromised host. By moving laterally, they can bypass security controls, discover new vulnerabilities, and establish multiple points of presence. This makes detection and eradication significantly more challenging for defenders. Lateral movement is a cornerstone of advanced persistent threats and targeted attacks. It enables attackers to pivot from low-value targets to high-value assets like domain controllers, critical databases, or intellectual property servers. This internal reconnaissance and expansion often occur silently, making it difficult for security teams to detect. The ability to move undetected across a network allows attackers to maintain persistence, even if their initial entry point is discovered and remediated. They can establish backdoors on multiple systems, ensuring continued access to the environment. Understanding these techniques is vital for any cybersecurity professional. Attackers employ a variety of methods to move laterally, often combining several techniques to achieve their objectives. These methods typically exploit weaknesses in authentication protocols, system configurations, or user behaviors. Recognizing these common approaches is key to building robust defenses. One of the most straightforward and effective lateral movement techniques involves the use of stolen credentials. Once an attacker compromises a system, they often attempt to extract usernames and passwords stored in memory or on disk. These credentials can then be reused to authenticate to other systems within the network. This technique relies on the common practice of users reusing passwords or having weak credentials. Attackers might also leverage tools to dump credentials from processes like LSAS on Windows systems. With valid credentials, they can log into other machines as legitimate users, often without triggering alarms. Pass the hash is a sophisticated technique where an attacker authenticates to a remote server using a user's NTLM hash instead of the plaintext password. This bypasses the need to crack the hash, making it highly efficient. Similarly, Pass the Ticket involves using a stolen Kerberos ticket to authenticate to services without knowing the user's password or hash. These techniques are particularly dangerous because they exploit the underlying authentication mechanisms of Windows networks. They allow attackers to impersonate legitimate users and access resources as if they had the actual credentials. Tools like mimicuts are frequently used to extract these hashes and tickets from compromised systems. Attackers frequently leverage legitimate remote services for lateral movement. Remote Desktop Protocol, or RDP, is a common target, allowing attackers to log into other machines graphically if they have valid credentials. Similarly, tools like psexec, a legitimate sysinternals utility, can be used to execute commands on remote systems. Windows Management Instrumentation, or WMI, and PowerShell remoting are also powerful tools that attackers abuse. These services provide robust remote administration capabilities, which in the wrong hands become potent lateral movement vectors. They allow for command execution, file transfer, and system configuration changes across the network. Beyond credential-based attacks, attackers also exploit software vulnerabilities on unpatched systems to move laterally. This could involve exploiting known flaws in operating systems, applications, or network services. A vulnerability on one system might provide a pathway to compromise another. For instance, a server with an unpatched SMB vulnerability could be exploited to gain access, which then allows the attacker to pivot to other machines on the same segment. This highlights the importance of continuous patching and vulnerability management across the entire network infrastructure. Lateral movement has been a critical component in many high-profile cyber attacks. The NotPetya ransomware attack, for example, leveraged stolen credentials and the Eternal Blue exploit to spread rapidly across networks. Once inside, it moved laterally to encrypt systems indiscriminately. The SolarWinds supply chain attack also heavily relied on lateral movement. After compromising the initial target, attackers used their access to move through victim networks, identify valuable data, and establish persistent backdoors. These incidents underscore the devastating impact of unchecked lateral movement. Detecting lateral movement requires a multi-layered approach, focusing on anomalous behavior rather than just known signatures. Monitoring authentication logs for unusual login patterns, such as logins from new source IPs or at unusual times, is crucial. Analyzing network traffic for suspicious internal connections or protocol misuse can also reveal activity. Endpoint detection and response, or EDR, solutions are vital for monitoring processes, file access, and command execution on individual endpoints. They can identify tools like Mimikatz or SecSec being used, or detect unusual process injection. Behavioral analytics and machine learning can help identify deviations from normal network activity. Preventing lateral movement involves implementing robust security controls across the network. Network segmentation is a cornerstone defense, dividing the network into smaller, isolated zones. This limits an attacker's ability to move freely, containing a breach to a smaller segment. Implementing strong authentication mechanisms, such as multi-factor authentication, significantly reduces the risk of stolen credentials being used for lateral movement. Enforcing the principle of least privilege ensures users and systems only have access to the resources absolutely necessary for their function. Regularly patching systems and applications closes known vulnerability gaps. Finally, continuous monitoring and incident response capabilities are essential. Rapid detection and containment of initial breaches can prevent attackers from establishing a strong foothold and executing extensive lateral movement. Proactive threat hunting can also uncover subtle signs of attacker presence before significant damage occurs. Understanding lateral movement is not just theoretical knowledge, it is a practical necessity for defending modern networks. By grasping how attackers spread, cybersecurity professionals can build more resilient defenses and protect critical assets from sophisticated threats.